Thanks everyone, my name is DavidWard. My talk does have a title. The title is Programmable WAN Networking is Safe for Work. So I'm going to give you perspective, being the last speaker in this panel, pulling together a number of ideas that I think that have been alluded to or directly addressed by certainly the folks talking about what's going on in the service provider space. But at the same time, I think you might find that the talk is actually not disagreeing, it's just different than what you've heard over the last couple of days on the vision for software-defined networks. I want to talk about a different aspect of what we can get out of SDNs. And really what it's about, and I think cost reduction as imperative goals, as we've heard the last couple of days, is a critical issue that folks are trying to handle with revenue declines or whatever the case might be. But in my opinion, really the most interesting aspect of this is in the fact that we can enable application innovation to work with the networks. This is what we want to unleash, in my opinion. We know that we take a look at iTunes stores and various other mobile applications and other applications that are coming up on the internet. These are lottery tickets to folks at this university and other universities and working in the industry. You don't know which one's going to win, but we know that what is going to win in the future is an application that delivers a better experience. And that better experience is probably best defined by starting off talking about where we are today. And where we are today is that we have a notion of network-aware applications, an application-aware networking that is fundamentally broken. And what I mean by that is applications are attempting to understand what's going on inside the network that they're running over. They're running ping stats, they're using geolocation stuff based on nav tech, they're using whois information, they're using Doppler, they're using a number of different mechanisms to actually try and figure out what's going on in the network versus asking the network. And conversely, the network is trying to figure out what's running over it. We've got DPI foo-bars, we've got deep packet flow state stuff going on left, right, and center, merely to find out what's traversing the network to try and maintain that SLA. This is a very expensive operation, and we can do better than this. Why? Because applications can program the network and tell it. That's what we're trying to enable with SDN technology. So how to ensure this best experience? Take the four actors in this play. The applications which know what they want to do, know what they're running on. Take the content which knows where it is in the network, or we can have the content understand where it is. Take the end users who knows what they want to do, and then enable this through a programmable network, and enable the network to give this information to applications. So why do we need to work together? Well, as I tried to describe very, very quickly, there is this divide between the two different worlds, those of application developers and those of networking. And my firm goal is to actually remove this wall that's in between these folks by unleashing this information. But it's critical, and this isn't something that you've heard much about in the last day and a half. It's bi-directional communication. The information has to come out of the network. Everything that Stu alluded to on what he wants to do in Verizon, he alluded to service profiles. He alluded to video delivery that he wanted to do. This is all making that application aware of the network that's underneath, and that information has to come out. Also, what's been alluded to, what's been alluded to by Stu and Stephen, but not discussed over the last day and a half, is in fact, not only are applications programming the network, not only is the network able to give information, we'll talk about this information in a second, but it's really that there are a multitude of new touch points where the network can be programmed. This is not necessarily just about top-of-rack switches or cheap hardware or whatever the case is. Instead, this is a fact that we have multiple touch points creating subscriber profiles, which today are programmed with radius and diameter that take eons to get out the door, that we can use things like OpenFlow to program new subscriber profiles and enable new services. Enterprise Edge, same way. New enterprise services, these edge routers are places that we can program. Hypervisor stacks with security information. We can create new billing profiles, and that might not be the most favorable thing to discuss, but really what it comes down to is when looking at a triple play or quad play service coming from, say, Verizon or any other provider like this, they're left simply with a high-speed internet queue to try and make revenue out of, for which they're giving away today for over-the-top services. It's the ability to program that high-speed internet piece, which is the dramatically largest growing aspect of traffic that they have, and derive services out of that, through programming into the network the applications that are using it or the profiles that they want to enable. Same with the others. So what is possible? So we do have the ability to tell an application where they're located in the topology. We can tell them the access technology that they're used to connect to it. We can tell that application the amount of bandwidth that's available, the utilization on that link, the real location in the topology versus necessarily navtech coordinates. This will allow those applications to deliver a better experience. And then, at the same time, with that interaction from applications that we have been discussing, beyond just creating virtual networks, we can allocate certain bandwidth for applications. We can, of course, enable new service topologies, which Stu discussed, security identifications, service identification, etc. And I'll give you a couple of use cases above and beyond what Stephen and Stu just discussed. But what's critical to me, and this is probably in direct disagreement with what was discussed yesterday, it's absolutely possible to integrate programmatic networks into the internet as it exists today. And the key is that we don't break everything. I think it's fantastic the Internet 2 people have built a network which they said, please come and break this. This is exactly what we want users to do to it. But at the same time, Stephen and Stu, for the love of God, don't break my network with the way you program it, or I'm not going to let you do it. And so the key is that these two things integrate together. And it's really about augmenting what's already on the internet. We've heard a lot about protocols are too complex and the rest of it. They do run the internet today. And so what's critical is that we realize that that's what's going on, but we also realize that we can augment the fact of these protocols with a programmable network. So let me just talk a bit about these protocols before I get into this interaction. As I mentioned, applications are attempting to derive what's going on the network through proprietary control channels. Believe me, nothing upsets me more than Microsoft Silverlight or Adobe Move having control channels to try and figure out whether they can run HD or SD video over a network when they can just ask. There's no need to have an API in both Silverlight and Adobe Move where it says how they use multiple TCP connections to get greater bandwidth. So once you understand that, you take a look at the API and it says, would you like 1 to 2,000 TCP sessions to deliver this video? What does every frat boy that programs Farmville do? They take the dial and move it to 1,000. Why? 1,000 must be better than 1. And so, no offense to anybody who's a frat boy coding Farmville. But my point is, these APIs are crazy. And they're crazy because the network has the information. I don't want anybody who's using Silverlight to actually know that, or Adobe Move to know that they may be querying the network. What is the bandwidth available between these two endpoints? Nobody needs to know that. They want to know, I want to optimize for HD, or somebody's paying less, for example, and they'll just take it, SD. So I think this type of interaction is absolutely possible. In addition, there's a number of different protocol touch points to enable software-defined networks. We've talked a lot about OpenFlow. Obviously, we're at an OpenFlow summit the last day and a half. But in fact, when you take a look at the history of protocols, the history of the internet, and I've been doing this thing for a little while, I've seen a whole lot of protocols come and go under the bridge. For programmatic networks, there's Corbas, there's COPS, there's GSMP, there's Forces, there's SNMP, there's XMLs, there's every incarnation that you can wave a rubber chicken over to try and make this work. But the difference, what we need to do this time versus all of those other times, in sum, is not take every aspect of functionality and drive it into one protocol. Every time that's been attempted, that protocol has been driven into the ground. There are certain things, there are certain protocols and certain functions that do things that others don't do, and potentially do them better. So towards this end, an SDN, in my vision, and what I'm trying to describe to you today, is that it's a plethora of protocols and interfaces to do a modular workflow approach to both get information out of the network and to program it in. Towards that end. An example would be a couple of these things in green here. PCE is path computation element. So when Stu discussed, I want to do bandwidth on demand. Well, all path computation element does is between two endpoints says, I would like to form an LSP between those two endpoints for this bandwidth. This is a perfectly fine mechanism to set up soft PVCs for LSPs. We don't necessarily need to program the entire path if he's already deployed a control and signaling plane. But what he can't do today is program those two endpoints. So that is the aspect of SDN that really becomes critical to enable some of these new features. and the fact that you can put in classifiers. There is no API or SDK available to routers or switches today that allows you to program ACLs other than the CLI or SCMP. That's inadequate. OpenFlow has solved this problem, and it's solved it extremely well. Towards this end, in addition, there's a couple of other interesting protocols that have come out. Alto is another one, application layer traffic optimization. This is where you're taking the topology out of the network, all of the routers, all of the links, all of the traffic engineering information, and you place where content caches, for example, or NATs, or firewalls, or DPIs, or any of these other fooBars are in the network. So when Stu or Steven want to send traffic to it, they can find the closest one. Again, proximity information is something, or where a user is in the topology is something that the network can tell you. I won't belabor the point in these protocols. But what's critical to understand coming up when looking at these switches and looking at these routers is that when we want to program the network or get the information out of the device or out of the network, what I've been just talking about with Altos and PCEs and even OpenFlow and passing things in IGPs like generic applications, these are deep down dirty APIs that, again, the Farmville crowd really shouldn't know a whole lot about. They need to be standardized, they need to be clear, they need to be modular workflow approach, but that's not what they're going to see. What they're going to see are the orchestration platforms on top. And that is what we want them coding to. And again, these orchestration platforms really become the basis, and I'll touch on this in a couple slides, for the entire movement of SDNs that we haven't talked about the last day and a half, but I think is critical to understand the larger scope of the SDN movement. To understand how these protocols build up for a second, let's just take a look at some of these pillars. We've got a query point. Where is something in the network? Can give you that topologic information, that location information directly from the network, including access technology, utilization, etc. We've got, I want to get from here to there. I can do that with PCE. We've got policy enforcement and provisioning. We can do that with OpenFlow and a number of other different mechanisms. And then we've got all sorts of really, really large Hadoop-type databases and others of where is something located in my network, which is a whole other aspect of innovation that we haven't touched in the last couple of days. But when you take all these protocols together, particularly with OpenFlow, I'm going to quickly summarize what a router looks like from a control plane in orange up at the top of some protocols and a routing information base, which is the big database that takes everything that comes into it and breaks loops and puts it into a feature path in the forwarding plane. And in my opinion, the hybrid activities we're looking for add OpenFlow as a mechanism to augment exactly what we have in routers and switches today. And that's where it fits in. And that's where these other pieces fit in to pull information back out of the network. So as we're doing this, there's, of course, another architecture inside routers and switches that Stu discussed and absolutely hasn't been discussed in a day and a half, which is we can integrate it, as you see on the right-hand side, or they can run ships in the night, which is the slice genie approach and many other approaches that we've talked about. The ships in the night approach, we know how to do this, right? Interfaces, resources assigned to this OpenFlow that's programming from the outside, good to go on your own, best of luck. On the other side, if we integrate them, then we can take the classifiers and we can take the information that we programmed with OpenFlow or those other protocols and put them into existing VPNs and have today's business services also enabled through this programmatic technology. Not saying anyone's better than the other, it's just that those two things I guarantee, rarely does this happen, but I guarantee that this is going to happen, that we're going to have both ships in the night and integrated coming out. I think it's basically overstating the obvious. This slide, we're not going to discuss, really, we'll discuss it tomorrow at 1 o'clock if you want to come to the hybrid forwarding path meeting during the working group sections. There are well-known technologies on how to integrate new protocols into routers and switches, break loops, add policy, and do the rest of it. But back to what the Farmville crowd is coding to. The Farmville crowd is coding to these orchestration layers. They're not coding to these crazy protocols I just mentioned. And there's general classes of these orchestration development platforms that we want to code to. It's not just one controller. There's operations and billing information. There's emerging network functionality that we discussed with unified communication yesterday. Emerging service-specific stuff, flow-specific information that Stu mentioned. And these new provider-based development platforms. So let's just pause here for a second These four, and particularly the provider-based platform, is in fact the largest wave of SDN that we haven't talked about in the last day and a half. And that's really because when you're all here on the peninsula, all of these plus more telephone companies, MSOs, service providers, all have application innovation centers on the peninsula. They are all trying to get the Farmville crowd to come and code weird, wacky stuff. 1 in a billion is going to make it. They want that one that's going to make it. They want to build an iTunes App Store. They are enabling this information via their orchestration layer of topologic information, as well as programming the network. This is what people will see. OpenFlow controllers will be underneath these orchestration platforms. And when you take a look and have read this bottom line, we are talking about over half the world's population, and 2/3 of the world's GDP are being addressed by these application innovation development platforms. So they become critical. So some of these examples, I think Stu hit some very, very key service provider WAN-based programmatic applications that we want to perform. I'll hit them as well quickly, a couple that he hasn't mentioned. We can take today's traffic engineering paths that are signaled via RSVP, and when we program classifiers in front of them with OpenFlow, we create basically service engineered paths. Because now we identify the specific service that we want out of these flows and put them into a specific either service topology or guaranteed reserved bandwidth over that network, and you can provide these new services that Stu was talking about. The next one for cost savings is that you can identify specific traffic, whether it's port 80 that needs to go through a deep packet inspection engine, or it's an address that needs to be NATed, program these classifiers into the forwarding plane, and take the, on average, 15 to 20 service appliances that are around an edge router today in networks like Stu's network. Think of it this way, every edge router, every subscriber terminating router is surrounded by service appliances that aren't pooled back into a data center today. To be able to pool these back and to have him get those cost savings, he needs to identify the traffic that goes to those application service engines or devices, and now he can pool them and have multiple edge routers share them through programming what he wants and new profiles via things like OpenFlow. We've discussed service-specific topologies already. What's interesting is that we also haven't discussed the second big database on the internet. We've talked about IP addresses and we've talked about how to do data planes, but we haven't talked necessarily very much about namespace information. And that's primarily through DNS. And what's interesting is that when we take the back end of object naming, which is what users go onto the net and try and look for, a movie, a web page, or whatever, they're using a name to be able to do this. We can take this information that's already in the network of where they're located and find the closest aspect of that particular content. So we use the information that's available in the network through things like Alto. We can do this across multiple providers. And what we do is we hand back the best place to go get that information based on, as you can read here, proximity, availability, congestion, utilization, load on that particular server. And you will get the answer, you can get an answer out of the topology of where the right place to go is and plug this directly into DNS. So let's take a look at this example. There's 3 users, New York, London, and Paris, and somebody wants to get something out of the network. They can go and ask DNS. Behind DNS is the application layer traffic optimization, which gives you the topology of the network, which gives you a weather report of the network. And from there, from those 3 things, proximity, availability, and congestion, it will take you to the closest content server. But the programmability of the network isn't done yet because, as we already know, content servers have specific performance and scaling characteristics. That goes without saying. So when you tie back into the ability to program service-specific information like availability, load, and capacity, that can, again, affect your proximity plugged directly into DNS bind cache the way a lot of common technology is done today. And again, we've got a better experience for that user working on the net. In this particular case, the answer for the person in New York was Chicago. Now, being from Minneapolis, Chicago is never the right answer, but in this particular case it is. And really what this is showing here is that you can use, based upon your location in the topology and the location of where you want to go in the topology, to get a better answer. We talked about bandwidth calendaring. Stu mentioned this. We can think of this as populating content caches. We can use this as data center backup. We can talk about enterprises that want to be able to do this information. But what's really required is that we have the ability to schedule and program into the network the bandwidth that you want reserved, when you want it, and make sure, this is the hard part and where programmable networking comes in, only the traffic that's supposed to traverse that link goes there. Because that's what we're trying to fix in the network. Instead of a new link coming in and all traffic suddenly going over that new bandwidth, let's only have that service-specific information that was being requested for this particular piece. So what do we need? We need a real-time topology understanding, steering the traffic, we need to reserve the transaction, and we need to select that specific traffic to traverse that link. My last one is, and one that really ticks me off, is social networking. And yes, it does. And it's not just because it drives me crazy that I have to pay attention to it. So what's interesting is that right now in social networking functionality, we're all trying to approximate where this particular user is, and there's a whole bunch of different techniques that and categories of social networking where it's happening. But really, what it comes down to is that the different categories of social networking and different ways of looking at this, they aren't using the information that's available in the network. Again, where are you in the topology? What is the access technology? What is the bandwidth? If you actually want to communicate with your buddy and you've checked in at some restaurant and you want to know where they are and where they're located, the three common mechanisms of doing this, of active broadcast, you're checking in, or you're doing a game broadcast that you're moving some new access link, or there's some passive derivation. These are crazy, antiquated ways of doing it, but they happen to be the state-of-the-art for social networking and location ID available in the net. We know if we get this information back out to them, we don't have the normal categories of something like Foursquare on steroids and being above the topology and trying to describe where people are, or visualizing the topology like NavTech, or trying to embed this stuff using the GSM coordinates into an operating system like Android or iOS. Having navigational coordinates and driving directions to where your friend is located does not equal a good social networking experience. But that's the current state of the art. We can do better than this. And we can do this by potentially, again, enabling applications to see you're here, you have this access, you have this capability, and around you is this content, resources, people, and the rest of it by being in the topology versus just trying to derive it as an application or sniff it if you're a network. So what did I just say? I went quickly, and it was a little bit different than what you've heard in the last couple of days. Basically, there's a lot of development platforms emerging, and there's a boatload of VC. There's been a lot more VCs and venture capitalists than I expected at one of these meetings until I came here a couple days ago. But nonetheless, the point is there's a lot of attention on building applications with better experience, which means building networks that can deliver that experience through flexibility of placement, fungibility of assets as we described, control of those resources. And what this means is that decisions are being made on the network, and we've heard this from Jeannie, and we know this is happening with Stu and with Stephen because they've described it very clearly. And as I mentioned, with all of those companies with application innovation centers that are telephone companies and MSOs, they're making networking decisions now on the construction of SDNs. And that is going to be the ticket that they're looking for to find the application developer that can build a better experience based upon SDN information. And on that, Stacy, I'll be done. Thank you very much.